For the English minor, it's my graduate student special project. I'm doing a Datalogger for the formal SAE team. For this year, the team has switched to a new engine controller that has a CAN bus and outputs all of the engine data on the CAN bus. So I have built with the launchpad, I've built a Datalogger. It has a CAN bus interface. It has the TM4C microcontroller. It also has 10 analog inputs. It has a 3-axis accelerometer, 3-axis gyroscope, and 3-axis magnetometer on the I2C bus, which I have not implemented yet. I also have a GPS on the serial port. This has been implemented. I also have 2 serial ports for data output in addition to the one that's built into the programmer. There's a XP wireless module socket, which I've currently populated with a Bluetooth module. I also have RS-232 serial. This unit also has an 8-volt 4-amp output for servo motors. There's also 2 digital outputs that can sync 2 amps, and 2 other outputs meant for electronic shifting, which can sync 20 amps. The Datalogger is in a cinch mod ice enclosure with a 30-pin waterproof connector. And I have 3 LEDs. Blinking blue means Datalogger is logging data. The orange light means the Wi-Fi or Bluetooth is connected, which is what this antenna is for. The green light means that there's a GPS signal. This connector is for the external GPS antenna. The module also has an internal patch antenna, which I'm kind of surprised to get signal indoors. And it saves data onto an SD card in the FAT file format. This is the first year we're using the Performance Electronics E3 ECU with CAN bus. This has a whole load of unused inputs you can use for wheel speed sensors and other sensors. And it has a CAN bus which broadcasts data at 250 kilobits per second continuously. And we have the engine. This is a Honda F4i RR engine. And we're still building the new intake and exhaust. So this is using some of the stock manifolds. And have the CAN bus connected with actually XLR microphone connector, since CAN bus needs to be a shield twisted pair, and microphone cables are shield twisted pair, so I didn't have to go buy new cables. Let's stop that. Okay, for this test, we have the engine in the dyno room. I have about 20 feet of CAN bus on these microphone connections coming into this test setup. There's also an Arduino with a CAN bus shield and a microchip CAN bus analyzer on the network. They're only receiving, and they're not doing anything useful for this test. And I have the Datalogger on the network. It is recording, and it has a Bluetooth connection to my tablet. So I should be able to start the engine and view the engine RPM data on the tablet computer. Okay, so now we're going to test to see if we can get live data out of the ECU. I have the Bluetooth connected and set the terminal program is set to output the RPM, the throttle position, the ignition advance, the air fuel ratio, which actually isn't hooked up, and the battery voltage once a second. If this shows up on the screen, I count the loop every second just to make sure it hasn't crashed. And some of these units are actually need to be multiplied by 10 or 1,000. So when it says volts, 1,390, that actually means 13.9 volts. So we're going to try and start the engine to see if we can read the engine RPMs. So this might not actually work, depending on if this engine starts. And it stalled. We're out of gas, but you can actually see when it's cranking, it goes up to 400 or 500 RPMs. Okay, so now we want to see if the has actually recorded the data to the SD card. I'll also demonstrate that the DAQ light changes on a light failure. If I take the card out while it tries the light blinks quickly, which means data logging error. The data is stored in the text file, and it's using a Windows type FAT file system, such that you can just put the file in the computer. Even though we did write a file system for class, I think a proper file system is the way to go. When the DAQ boots up, it goes into a loop where it checks to see if a file number exists. If it doesn't exist, it increments the file number and tries again until it finds a file. If I open this in Notepad++, it's a large file since this has been running for several hours. I show the data, and the format of this is CAN data is printed along with a timestamp, and it has the raw CAN packet. I accept all CAN packets on the network since I don't feel the need to filter out CAN packets since there's only one device talking on the network. I show the ID, the length, and the bytes, and whenever GPS has data, I say GPS, the timestamp, and the raw GPS NMEA data. This timestamp is in units of hours, minutes, seconds, and milliseconds, with 0 defined as when the DAQ is powered up.